Good afternoon, everyone. I hope I'm audible.
Yes, Satna. Go ahead.
Yeah. I'm presenting here face emotion recognition from video using CNN and transformers model. This research work is done by our Accenture team, including Prabhitha, James, myself, Selva, and Subhashini Lakshmi Narayanan. Yeah. So emotion detection is a very important subject in research area. Many researchers are working on this. Emotion represents a psychological condition which plays a very crucial role in our life decisions. So the face expression and the tones of the voice can be used to represent human emotions. So as this is very important subject, so the researchers have been attracted to work on this since many years in different fields. So researchers have been working on this model in order to automatically understand the emotions that people expresses through the writing, speech, gesture, and the facial expressions. So the complexity of the process of the detection of person's emotions is because we can say it is understandable due to the versatility of the emotions and the cultures and the genders and ethnicity of the there are the different reasons for this. So considering the point that the technology and the social media have reached today, we can say that besides the interaction in the daily life, people constantly express their emotions through the different channels such as text, voice, and video messages. So this has given importance to emotion recognition research. Hence this research field is gaining importance and acceleration, since the gesture and the facial expressions are important ways of expression emotions. So emotion detection in photos, videos become very popular. So this research, in this research also, we are going to use the video data set from the open source available data set, that is Revdas, which is Ryerson audio visual data set of emotive speech and songs. This is a widely used data set for the human emotion detection. As this is the multimodal database, it is a combination of speech and video songs. On this data set, this data set is consists of 8 emotions such as anger, calm, fear, happy, sad, and disgust, surprise, and neutral. So these different classes of the data set are there. The video clips in this data set are around 3 seconds and have a frame rate of 24 frames per second. So for this, in this work, we incorporated the visual information, which is rarely used modality from this data set, due to the difficulties associated with the working with the videos. So, however, our research shows it is a valuable source of information that should be explored and improved in the current emotion recognizer. Because in our literature survey, we referred more than 30 research papers where it shows that many of from this data set, they have used both audio and visual data set, which increases the complexity of model. So we only use the video part of it. It is in that sense, we can say it is a single model database we used from this to in order to reduce the complexity of the model. So in this research, we explore the transformer based visual emotion identification system to overcome these issues. This work is based on validating the readers data set, and we performed the simulations with the help of different CNN models and string transformer. So this is the double fold, which shows the double fold increase in accuracy while when we simulate it on a swing transformer as compared to the other best model from the CNN transfer learning. So next, over to you, Prabhita. You can explain the methodologies in the next.
Thank you, Arna. So coming to the methodology part, what we have done is, our input is the video data set, which is the RaveDust data set. So the pre-processing, what we have done is, like, we first converted the video into multiple frames. Then we used the OpenCV's hard cascade classifier to detect and extract the faces from the frames. So then what we have done is, we prepared the input features for the model using some feature extractor. And then finally, we resized every image in our data set to a resolution of 224 cross 224 cross 3. So this is the pre-processing which we have done in general for all the models. But for the CNN models, that's a convolution models, we specifically done few more pre-processing steps, we have done image augmentation, like by shifting the images vertically, horizontally, so by doing those steps, we increase the amount of input data set too. So these are the pre-processing which we have followed. So basically, what we have done is, so we have our input data set, which is a RaveDust video data set. So we fine-tuned many models on this particular data set and compare the performance and other things in these models. So coming to the first one, we have used a transformer model called Swin Transformer. So basically, how a Swin Transformer works is, if you provide an input image, it will divide the input image into 16 cross 16 patches. Then these patches will be converted into patch vectors by some linear transformation. And then finally, we will add some positional embeddings to these patches. Then we will provide the output of these, the patches plus positional embedding. So we will get some output. So we will provide that output to a transformer model. So this is how a basic Swin transformer works. So what we have done is, we fine-tuned this Swin transformer on this RaveDust data set. So and we done some feature extraction. We done the feature extractor of the Swin transformer does the padding and normalization operations. Also, we have used the pre-trained model from Hugging Face, and we only fine-tuned the model. So also, how we fine-tuned this, we took the last output of the last hidden state of the transformer and gave that output to a dropout layer with a ratio of 0.1. Then finally, we added a linear activation layer to classify the emotions. Also, we use the loss function we use is a cross entropy loss function. Next, this is a transformer model we have used. And then coming to the conventional CNN models, the first one is which we have used is VGG16. So basically, VGG16 is a 16-layer neural network. So here also, again, we didn't train it from the scratch. We use the pre-trained VGG model, which is basically trained on the ImageNet data set. What we have done is, we took the output of the pre-trained VGG16 model and then fed that output to an average pooling layer, and then passed it to 3 dense layers with a ReLU activation function. And then finally, we again added a dropout layer with a ratio of 0.5. So at the end, we added a softmax layer to classify the 8 emotions. Moving to the next one. So then again, another CNN model which we have used is the VGG19. So same way here also, we have used the pre-trained VGG model. So we again then took the output of the pre-trained model. Then again, on top of that, we added an average pooling layer. So basically, we added a pooling layer to reduce the dimensions of the image. And then we added a dense layer with a kernel size of 512 with the ReLU activation function. Also, we added a dropout layer with a ratio of 0.5. So we mainly add the dropout layer in order to prevent the model from overfitting. And at the end, we added a softmax activation function to classify the emotions. The next model which we have used is VGG19 plus ResNet 152v2. So then we thought, okay, instead of using a single model, we will try a hybrid approach. So here what we have done is, we took 2 state-of-the-art models, VGG19 and ResNet 152, and then we combined both the models. So as the first step, what we have done is, we took the VGG19 model individually, the pre-trained VGG model. Then we added a dropout, average pooling layer, then some dense layers and a ReLU activation fluctuation function and kept that output. And then again, we took the ResNet 152 model. So same way we have done an average pooling layer, but instead of one dense layer, here we have added 3 dense layers with different kernel sizes and 2 dropout layers with a ratio of 0.5. So now we had a VGG19 model and ResNet 152 model. So here we have combined the output of these 2 models, and then again we applied 3 dense layers with different kernel sizes. And at the end, we used a softmax layer to classify the emotions of the person. So that's what we have done with this one. Next, coming to the DenseNet, the another CNN model which we have used is the DenseNet 201. So DenseNet 201 is nothing but is a 201 layer deep neural network. So basically why we went for this approach is, if you see, for this model is in DenseNet 201, instead, in addition to the feature maps at the current level, what it does is it will consider the output of the preceding layers also. So that because of that, what the advantage we have is we will have the collective information of the preceding layers. So that's the reason we chose DenseNet 201. So here again, same way we have took the pre-trained model, which is trained on the ImageNet dataset, and then we applied an average pooling layer and 3 dense convolution layer and true dropout layer to classify the emotions. So basically we have used these 4 convolution models and 1 transformer models. So this is our methodology part. Moving to the next slide. So here I'm going to talk about the results. So what are the results we achieved by fine tuning our data set on these different models? So if you look at this tabular column, we can infer that the Swin transformer model, with Swin transformer, we achieved, like if you look at the last line, with Swin transformer, we achieved 91% accuracy. Both F1 score and accuracy, we reached around 91%. But if you compare the other CNN models, the best one which we could get is from VGG19 plus ResNet 152. That is from the hybrid model. We achieved like 49%. So, and then if you look at, if you if you use the VGG19 individually, then we were able to achieve only 39%, but the hybrid model at least give a 10% increase. So with that, we achieved 49%. Also, okay, and if you look at the least one, the DenseNet. So with DenseNet, we were able to achieve only 31%. So these are the results we achieved from the different models. Next, moving to the conclusion part. So basically in this research, we used transformer model and convolution models and fine-tuned on the Ravedes video dataset to detect the facial emotions. So we also fine-tuned many hyperparameters like learning rate, batch size, and number of epochs. Also, we use Adam optimizer and some weight decay of 0.01. So basically, we tuned our model on different hyperparameters and finally took the best results out of it. And also, we evaluated our model using different metrics like accuracy, precision, recall, and F1 score. And if you look at the results, it is very clear that the Swin transformer outperformed all the other convolution models on the emotion classification task by a large margin. So, like in this, with transformer, we achieved like 91% accuracy, but with the convolution models, we were able to achieve the best of 49%. So it's like a double fold increase in accuracy. Also, it is very clear that the transformer models have a very high impact on the vision data set. Also, if you compare, and then when we compare between among the traditional models, we could see like the best accuracy which we were able to achieve is 49%, which is obviously very less compared to the transformer models. Even we tried increasing number of epochs, like we tried till 50 epochs for the traditional models. Even though we tried till 50 epochs, we were able to achieve only 49%. But if you look at the transformer model, even after 10 epochs, we were seeing a significant increase in the accuracy and F1 score. Also, if we compare the other, same thing, among the convolution models, the hybrid model is better compared to the other models. So these are the observations which we made from our research paper. Yeah. Thank you all. Thank you for the time. Let me know if you have any questions.
Good work. I just wanted to know, like, in a casual question, the
Mhm.
face changes, like when you would have done for one type of face structure. There are different face structures for how you, play your emotions out there. Like, how would you given the codes or recognize out there? Is it for the same outline of the face you will be designing, or like what exactly it is?
So what we have done is, so I mean, we took the Ravenous data set, right? So this is like we have like the data of 24 different actors. So it's the actor data set. So each actor, with each actor, we have like 120 videos, which is of 3 seconds length. So this is our actually we set the data set to this open source data set. So what we have done is we took the video and then we converted. I mean, basically, video is nothing but a sequence of frames. So we converted the video into sequence of frames. So we will know, like I mean, in a video we can have multiple people, or we have to identify those things too. So what we have done is, after converting the video to frames, we have used the OpenCV's classifier to detect the faces in the image. Because like in an image we will have like a lot of information which is of no relevant to our classification task. So what we have done is we have used this classifier to detect exactly the faces of the people in that images, and then we crop those images and resized it according to our need. And then now if you see the video data set, basically we converted into an image data set which contains only the images of the people, I mean faces of the people. So easily we can use our different, I mean, transformer and the convolution models to detect the emotions from those images. So is that answers your question, or am I missing something?
No, thank you. Okay.
Okay.
Sounds good.